Okay. So it is recording. Can you see that it is recording? Just to make sure, yes, it is recording. So today
Yes,
we'll
doctor.
do section 7, which is the last section of this chapter. And it is about, sorry, I forgot to do one thing. It's about the buoyant force. And as you can see, probably you feel that when you go into the water, if you go swimming, if you can swim, do you feel that your weight in the water is heavier, is larger than that in free air, in air, or lighter? Do you feel heavier or lighter while you are in the water?
Lighter.
You feel lighter. Yes, you feel lighter. Every time you go swimming, you will feel that as soon as you are into the water, that your weight has decreased. So the apparent weight in water is definitely smaller than it is in air. So why is it when we are in water, we feel lighter? Okay, we will study this phenomenon today is why do you feel lighter in water? And in fact, even if you want to carry an object and that object is in water, you feel that its weight is smaller than its weight while it is in air. Okay, today we will be seeing why this happens. So in our life, we may experience the following. In a swimming pool, you feel you have lesser weight than in air, which I mean when you are outside the pool. So in water, you feel lighter. Why does this happen? In fact, what happens is that when you are in a liquid, which is water, we swim in water. When you are in the water, يعني لما تكون في المية, there is a force from the liquid that pushes you upwards. يعني في قوة من المية أو من السائل لوين بتدفعنا هاي القوة؟ Upwards. You are pushed upwards by that force. That force comes from the liquid and it is called the buoyant force. Buoyant force يعني قوة الطفو. Okay, اسمها قوة الطفو. That's what buoyant force means, which makes you, or which acts, that force acts on you vertically upwards. بالعربي بيسموها قوة الطفو. Okay, that's what it's called, قوة الطفو. So where does that force come from? What causes this force? Okay, so now we want to understand the physical origin of that force. To do that, look at this cylinder. It's a cylinder which is in a liquid, مائع. We will take it water for simplicity. It can be any liquid. Okay. Now, you see that the top face of this cylinder, or the top surface of this cylinder, it is at a height h1 below the surface of the liquid, while the bottom surface of the cylinder here, it's at a height of, or at a depth of h2 below the surface of the liquid. Now I want you to tell me which surface experiences higher pressure from the liquid. Is it the top surface or the bottom surface? Where is the pressure higher? Here at the top surface or here at the bottom surface?
Bottom
Yes,
surface.
it's at the bottom surface. Why? Because we know that the pressure of a liquid is proportional to the depth below the surface of that liquid. Now, the top surface, it's at the depth of h1. The bottom surface, it's at the depth of h2. h2 is larger than h1. Therefore, the pressure at this bottom surface is greater than the pressure at this top surface. So what does this mean? Now, note that this is a cylinder and those two surfaces are equal. The surface area of each one of them is the same. But can I calculate the force at the top surface? The answer is yes. Okay, how can I calculate it? Very simply, we can do the following. I know that the pressure P1, which is the pressure acting at the top surface, is raw fluid, the density of the fluid, G times H1. And if I want to find the force that is acting at this surface and it's vertically downwards, that force equals to the pressure P1 multiplied by the area. And so I will get the force equals, instead of pressure, I evaluate raw fluid G times H1 multiplied by A. So this gives me the force that acts on the top surface vertically downwards. اوكي، هاي هي القوة اللي بتأثر على السطح. مين؟ بتأثر على السطح العلوي. من وين جاي هاي القوة؟ بضرب البريشر، الضغط الناتج عن الليكويد عند هذا السطح، ضرب مساحة السطح. طيب similarly بنفس المفهوم, this also applies to the lower surface. Now the force that acts on the lower surface, as you can see, it's vertically upwards. The liquid pushes the cylinder from down up, the upwards direction. So what is that force? I know that the pressure P2 equals to raw fluid GH2. H2 is the depth below the surface of the liquid, and therefore the force F2 is the pressure that acts on this surface multiplied by its area, and therefore it's the force is raw fluid GH2 times A. So now I have calculated both forces. Which force is larger? Is it F2 which acts upwards or F1 which acts downwards?
F2.
F2 is larger. Why? Because P2 is larger. Yes, why? Because H2 is larger than H1. Therefore, the resultant force that acts on this cylinder due to the liquid, is it upwards or downwards? The resultant force of F2 and F1. Since
Upward.
F2 is larger than F1, then this force acts where? Upwards. So you see that the liquid pushes any object inside it where? Vertically upwards. This resultant force is called what? It's called the buoyant force. It's called the buoyant force أو قوة الطفو. So why do we have a buoyant force vertically upwards? Because as you go down in the liquid, the pressure increases. The buoyant force is really a direct consequence of the increase in pressure as we go deeper below the water surface or the liquid surface. يعني قوة الطفو هي نتيجة مباشرة إلى زيادة ضغط السائل مع العمق. Since this space is at a larger depth than this space, the force here is greater than the force here, and the resultant force due to the liquid, يعني محصلة القوة الناتجة عن السائل وين بيكون اتجاهها؟ Vertically upwards. And that's what we call what? The buoyant force. Okay, so I have written this down. Note that P2 is greater than P1, and therefore F2 is greater than F1. And the liquid acts with the resultant force. You see, the liquid acts with the resultant force. يعني في قوة محصلة جاي من السائل where? Vertically upwards on the cylinder. This force is called what? The buoyant force. قوة الطفو. طب I want to calculate this buoyant force. Simply, we call it FB, buoyant force called FB. This is the buoyant force. Buoyant force, and it's going to be the difference between the bottom force and the top force. F2 minus F1, which is raw fluid, H2 minus H1 times A times G. I just evaluated for F2 and F1, and that will be equal to raw fluid times delta H, which is the height of the cylinder basically, multiplied by A multiplied by G. But remember, delta H multiplied by A, what does it represent? This is delta H, which is H2 minus H1. If you multiply this height, which is delta H, by the area of the cylinder, what do you get?
Volume.
Volume. أحسنت. Yes, it's the volume of the cylinder. يعني حجم مين؟ حجم الأسطوانة. Okay, and therefore delta H times A, which is this, is the volume of the cylinder, which equals to the volume of the displaced fluid. And what do we mean by displaced fluid? Displaced fluid means السائل المزاح. شو يعني السائل المزاح? What do we mean by that? And imagine imagine this cylinder was not in the water, it was outside. You will have, maybe the water level will be up to this level here, okay? Now, when you put that cylinder inside the liquid and all the cylinder is inside the liquid, what happens to the level of the liquid? Does it go up or go down? مستوى سطح السائل.
Up.
Up. Why? ليش بيطلع up؟ لأنه this cylinder displaced a volume of fluid equals to the volume of the cylinder. يعني لما تحط السلندر داخل المي، هاي السلندر لها حجم، راح تاخذ مكان حجم الميه. وين المي هاي اللي زحتها بدها تروح؟ بدها تروح للاعلى. This is what we mean by the displaced fluid. Displaced fluid means the fluid that has been moved because of the volume of the object that we place in the water. As soon as you place the cylinder in the water, the level of the liquid goes up. Why? Because that cylinder takes up a volume. It displaces the water, it moves the water. Where does the water go? It goes up. طيب, imagine that we had a container like this. This is a container. And it is completely filled with water. Up to the rim. Completely filled with water. Like this. What happens if you place a cylinder inside it? Yani this is the cylinder now. This is a cylinder. I want to place this cylinder inside. Okay, I want to place this cylinder. This is a cylinder I want to place inside the liquid. Now what happens to the water? What's going to happen?
تطلع لبرا.
بالضبط. It will spill out. هتطلع لبرا. ليش؟ لأنه the cylinder has a volume. Okay? The cylinder has a volume. And that container is completely filled with water. It is full with water. Okay? This is the water now. Now we have the cylinder inside. The cylinder is now inside. It has taken a volume. So what happens to the water? It spills out. Okay? For water comes out. Water spills out. Okay, this is the displaced water. This is displaced. هذا المقصود بالdisplaced water. Displaced liquid. Now, since the object is fully under the surface of the liquid, this cylinder is fully submerged in the liquid, the volume of the displaced fluid will be equal to the volume of what? Of the cylinder. Yani let's suppose that this cylinder has a volume of 100 centimeters cubed. How much volume of water will come out? لو هذا 100 centimeters cubed. 100 centimeters cubed, exactly the same volume as the cylinder. Okay, so that's what we mean by the displaced fluid. Okay, so we can say the following: buoyant force, قوة الطفو تساوي raw fluid. This is raw fluid. Delta H times A is the volume of the cylinder, which equals to the volume of the displaced water. Why are the two volumes equal? ليش حجم السائل المزاح يساوي حجم الأسطوانة? The reason is the cylinder is completely immersed in the liquid. يعني الأسطوانة هاي تماما مغمورة تحت سطح السائل, and therefore the volume of the displaced fluid equals to the volume of the object. طيب, you have raw fluid multiplied by its volume. طيب, density multiplied by volume, what does it give? You multiply density by volume, you get the mass. You get the mass. So this is the mass of the displaced fluid, mf. If you multiply it by g, which comes from here, you get mf times g, and this is the weight of displaced what? Fluid. So what is the buoyant force? The buoyant force is the weight of the displaced fluid. in any fluid, the buoyant force that acts on an object equals what? Equals to the weight of the displaced fluid. And this is known as Archimedes' principle, اللي هي قاعدة Archimedes, which states the following: buoyant force on an object immersed in a fluid، يعني قوة الطفو المؤثرة على جسم مغمور في الماء شو بيساوي؟ equals the weight of the displaced fluid. Equals the weight of the displaced fluid، يعني قوة الطفو المؤثرة على جسم داخل مائع تساوي وزن المائع المزاح. That's what it equals to. اتفقنا؟ This is called what? This is called Archimedes' principle أو قاعدة Archimedes. So the more fluid the object displaces, the larger the buoyant force that acts on it. كل ما كان حجم السائل المزاح أكبر. طب ليش هو مزاح؟ لأنه أنت حطيت الجسم داخل السائل فالسائل راح يحصل له انزياح. كل ما كان the volume of that or the mass of that fluid larger, the larger the weight and the larger the buoyant force. So this is Archimedes' principle. Now the question is, why do some objects float؟ يعني بعض الأجسام في المي تطفو. أعطوني شيء لو حطيناه في المي يطفو. Give me an example of an object. If we place it in water, it will float. Float يعني تطفو على السطح. مثل مين؟
خشب.
خشب، plastic,
بلاستيك.
polystyrene، مش هيك؟ Even if you try to push it inside the liquid and you leave it, the liquid will push it up until it goes up to the surface. طب give me an example of an object that will sink. sink يعني يغرق. حديد.
Iron.
iron.
Gold.
حديد. gold. lead. a rock. Okay, all those will sink. So what determines if an object floats or sinks? How do we determine that? Okay, look at this. The cylinder in the above example has two forces that act on it. One of them is the buoyant force upwards, which equals to the weight of the displaced fluid. Rho fluid times V fluid times G. What is the other force that acts on the cylinder? Its mass. Also its mass acts on it. طيب, if the object floats, what does it mean to you now using Newton's second law? When does this cylinder move up?
When the buoyant force equal to it.
Equal to the weight? لا, إذا equals to the weight, it will not float up. It will not move
When
up. It's
more
going to be
than more.
greater. Yes, when the buoyant force is greater than the weight, we will have a resultant force of those two forces that acts upwards, and the object floats. طيب, when does it sink? متى بيغرق?
when the weight is more than FV.
Yes, when the weight, الوزن, is greater than the buoyant force. أكبر من مين؟ من قوة الطفو. When the weight is greater than the buoyant force, it will what? It will sink. طب if they are both equal, it will hang
معلق.
its equilibrium. Yes, راح تكون معلقة. Okay, طيب. Let's formulate this a little bit more. I have written down FR. FR is the resultant force acting on the cylinder. Now the cylinder has two forces acting on it. The buoyant force vertically upwards, which is the difference between the force from the liquid upwards and the force from the liquid downwards. And that is vertically upwards, we call it the buoyant force, and it's the mass times G, which is the weight. Now the resultant force, if I take upwards as positive, will be F buoyant minus the weight mg. This is the weight of the what? Of the cylinder. The buoyant force we just found up a minute ago, it's rho fluid, which is the density of the fluid, multiplied by the volume of the displaced fluid. And I am going to repeat this for the last time. The volume of the displaced fluid equals to the volume of the cylinder, because all the cylinder is under the water or under the liquid. minus mass of the object multiplied by what? Multiplied by G. Let me have here object 2. This is the mass of the object. This is mass of object. Mass of object. Just to make sure what you are looking at. Mass of object. مين هو الأوبجكت هون؟ cylinder. طب what is the mass of the object? It is the density of the object multiplied by the volume of the object, which equals to the volume of the displaced fluid, in this case, multiplied by G. Now, as you can see, V times G is a common factor, and you get the resultant force that acts on the object is rho fluid minus rho object multiplied by Vg. As you can see, Vg is a common factor. Now, tell me, when is the resultant force upwards? What conditions must be satisfied? Upwards, since I have taken upwards as positive, it means that Fr must be positive. So it acts upwards. What is the condition that must be satisfied for this to be positive, i.e. upwards? شو الاشي اللي لازم يتحقق حتى هي تكون موجبة؟
Raw fluid
أكبر من أيوة أكبر من rho object. So if the density of the fluid is greater than the density of the object, then the object what? Floats or sinks?
float.
Floats, yes, it floats. ولذلك plastic has a smaller density than water, so it floats. Polystyrene has a density smaller than that of water, it also floats. لكن iron does it have a density of smaller than water or larger than water?
Larger.
Larger than water. For iron, rho object is greater than rho fluid. So rho fluid minus rho object is negative. Negative means it acts downwards, and so it sinks. I have summarized this here. Rho fluid greater than rho object. It means that the resultant force Fr is upwards and object floats. Rho fluid is less than rho object, like iron and water. The resultant force is downwards and object sinks. It means that the weight is greater than the buoyant force and the object sinks. Okay, that's why a nail sinks in the river or in the sea. A nail will sink, but a log of wood, for example, يعني قطعة من الخشب will float. A piece of plastic will float. Okay. طيب, let us say the following. Objects whose densities are greater than the density of the liquid شو بصير فيهم؟ sink. يعني الأجسام اللي كثافتهم أكبر من كثافة المي شو بصير فيها؟ تطفو أم تغرق؟ تغرق. Objects that have larger density than water, for example, will sink. If I ask you now, after all this, what is the real cause of the buoyant force in a liquid? ما هو مسبب قوة الطفو في السوائل في الموائع بشكل عام؟ ليش بصير عندنا قوة طفو؟ شو السبب؟
الضغط على السائل.
The pressure of the liquid increases with depth below the surface. This is the reason why we have what? A buoyant force. It means that the force of the liquid that acts on us upwards is greater than the force that acts on us from the liquid downwards, and the resultant force from the liquid is vertically what? Is vertically upwards. طيب, let me ask you this question. We said that iron, steel, gold, lead, they all have density higher than that of water, and they will all sink. So what is a ship made up of? Ship, سفينة من ايش معمولة؟ مش معمولة من الحديد، فيها حديد، فيها lead، فيها steel. طب their densities are greater than that of water. Why doesn't it sink?
الحجم
ليش
كبير
السفينة ما بتغرق؟
سمعتها بتكون
why
حجم كبير.
لا مش شرط يعني you need to be more specific.
قلل الكثافة يعني.
كيف؟ صحيح، كثافة بنقللها بس كيف؟
معمولة
ايه Okay, let me give you a hint. أنا مش
لأنهم
رسام
مجوفين.
I have very bad drawing abilities.
دكتور
But yes.
لأنها مجوفة بتكون مش
أحسنت.
مظبوطة.
Yes, مجوفة. مجوفة. It has an evacuated volume. If you look at the ship, it looks like this. زي ما حكيت لكم عن القدرات الفنية تعيسة، بس the ship has an evacuation. This is the ship, okay? And this is the rest of the ship here. Now this is volume. This volume is what? It's full of air. This is air here, okay? This vacuum, this air, this volume of the ship is full of what? Is full of air. And so this volume here, volume evacuated volume مفرغة يعني contains what? Contains air. هواء. هي the ship مفروض تكون. طيب when you divide the total mass divided by the total volume, you get an average density smaller than that of what? Of water. Okay, that's what happens. All ships have vacuum underneath. It does not have steel there. This volume here is void, empty. It will be full with air. So when you divide that, okay, we have steel. When you divide the total mass of the iron and the steel and the rod and the load and everything by the total volume, and the total volume includes this volume. Now you have air here, which has a very low density, and the total density will be smaller than what? Than that of water. So here, maybe this word is not very clear. This is an evacuation. This is vacuum full of air. يعني هاي ما فيها lead ولا فيها steel. هاي evacuated. This is evacuated. Evacuated volume contains air. Okay? يعني شو فيها؟ مليئة بمين؟ مليئة بالهواء. So the ship has an evacuated space which is full of air, مليء بالهواء. So when we divide the total mass, لما نقسم الكتلة الكلية of the ship للسفينة by its total volume على حجمها الكلي اللي بيحتوي هذا الهواء, the resulting density is less than that of seawater, and the ship what? Floats. Okay? فهون احنا always when they manufacture ships, they make sure this is an empty volume, so that when you divide the total mass by the total volume, you get an average density which is smaller than that of water. Now let us consider another example, just to make sure we understand what we mean by buoyant force. Two pails of water. Pail يعني container. يعني two containers of water, let's say. Consider two identical pails of water. And I said, pail يعني container, يعني take or consider or think of two identical containers of what? Of water, filled to the brim. ايش يعني filled to the brim؟ يعني مليئة إلى الأخير. Full, they are full of water. If you place any object inside it, what happens to the water? It spills out. Okay, it's exactly like what I drew up. Okay, this is the first container, let's say, and it's full of what? It's full of water to the brim. Full of water to the brim, يعني it is absolutely full of water. You cannot add any more water. If you add any more water, what happens to it? It spills out. إذا بتضيف أي قطرة مي زيادة شو بصير فيها؟ تطلع برا. This is one pail. The other pail is here. Is an identical one. Exactly has the same volume and exactly has the same amount of water. Okay. Now the question says, let's see what it says. One pail contains only water. يعني واحد منهم فيه مي فقط. The other has a piece of wood. لاحظوا حكى wood. شو يعني wood? It will float. Floating in it. يعني هذا ما في شيء، وهذا حطينا شو في يعني كانوا اثنين نفس الشيء. يجينا حطينا هون a piece of wood. Remember, the piece of wood will what? Will float. يعني part of it will be below the surface and part of it will be above the surface of the water. Okay? Which pail has greater weight? Okay, مين منهم الآن لو if we weigh this and we also weigh this, which one has more weight? مين فيهم الوزن له أكبر? Tell me. Which one do you think has more weight?
نفس الشيء.
نفس الشيء؟ Why؟ هو صحيح نفس الشيء صح.
السائل بيطلع برا لما
أيوة أحسنت. Yes, they have exactly the same mass. Why? The question is why. And when remember before this was not here and both of them were full of water. طيب when you place this piece of wood into the water, it is going to displace what? A volume of the water. صح ولا لا؟ مش راح يعني هاي اللي هون basically this will be هذا الفوليوم تبعه. الآن that volume is under the surface of the water. طب وين راحت المي اللي كانت هون؟ Where did the water here go? It will spill what? It will spill out. Water will come out. Displaced water. Here I will have displaced water. Remember, the weight of the displaced water will be equal to the weight of what? Of the object. So if you displace 10 newtons, this will have a mass of a weight of 10 newtons. Suppose this has a weight of 100 newtons. How much is the weight of the displaced water? It will also be 100. يعني you added 100 newton. Okay, no problem. You will think maybe this container will be 100 newtons more than this container. The answer is no. Why? Because this 100 newton object has a weight of 100 newton. It will displace how much weight of water? 100. Okay, so you added 100 newtons of weight, صحيح, but at the same time you moved out 100 newtons of weight. So you added 100 newtons, you lost 100 newtons. What is the net? 0. And so the weight of this container after the water spills out will be the same as the weight of this container. So both containers will have what? Will have the same weight. Very simply because, I will repeat this for the last time, this object will displace a weight of water equals to its own weight, and as simple as that. Okay, if it is 200 newtons, it will displace 200 newtons of water out. If it is 300 newtons, it will displace 300 newtons out. So you added 300 and you lost 300, there is no change. So both pails will have what? Both pails will have the same weight. And what I have said is explained fully here. This example is taken straight out of your book. أنا أخذت هذا الexample من كتابكم. You can go back and see it. Okay. Before I move on, do you have any questions?
دكتور
Yes.
يعطيك العافية. بس عندي سؤال هلا، مش الفوليوم الديسبليس تبع الديسبليس ووتر نفسه تبع الوود الفلوتينج هلا هاي؟
The volume of the displaced water here equals to this volume of the object below the surface. بس. In this case, the two volumes are not equal, but the masses are, the weights are equal. We will come to what we call partial submersion. هذا بيسموه انغمار جزئي. راح ناخذه كمان شوي.
يعني لو كانت كلياتها نازلة بتكون
يعني انت قصدك لو حطينا مثلا حديد. لا، it's different. Now ليش احنا اخذنا هاي بالذات؟ لانه in this case هي انا كنت بدي اشرحها when I come to partial submersion. Note, this object is in what? In equilibrium, مظبوط؟ It means the buoyant force that acts on it upwards equals to what? To its weight. صح ولا لا؟ ليش؟ Because the object is floating. The buoyant force for a floating object which acts upwards is the same as the weight of the object. يعني imagine you have an object, it is stationary, معناته the force that acts upwards equals to the force that acts downwards. طب what is the force that acts on object downwards؟ شو هي القوة؟ مش وزنه؟ وزنه، صح ولا لا؟ طيب إذا البوينت force for an object that is floating equals to what? Equals to the weight of what? The object. And remember, the buoyant force also equals to the weight of the displaced fluid. صح؟ And the buoyant force equals to the weight of the displaced fluid. At the same time, the buoyant force equals to the weight of the object, and therefore the weight of the displaced water equals to the weight of the object. So if you have 100 newtons weight, it will displace 100 newtons of water. لكن if you have, for example, iron, hadid, is it going to float? Hadid, is it going to float or sink?
Sink.
Can I say that the buoyant force equals to the weight of the piece of iron؟
لا.
أقدر أحكي هذا الحكي؟
It's less.
ليش؟ مش لا. لأن لو كانت البوينت فورس equals to the weight, it will not sink, it will float. صح ولا لا؟ What happens is the weight of iron will be greater than what? The buoyant force. صح ولا لا؟
صح كده.
That's why it sinks. طيب if the weight is greater than the buoyant force, معناها the weight of this object is greater than the weight of the displaced water. صح ولا لا؟
صح، فبيكون أكبر.
إذا which one will weigh heavier, this container ولا this container؟
اللي فيه ايرون.
Okay, I'm glad you asked this question. فإذا كان الأوبجكت, if the object that you place partially submerged, يعني بيكون يطفو على السطح لا يغرق, the buoyant force that acts on it upwards equals to its weight. طب مو at the same time the buoyant force equals to the weight of the displaced fluid. معناها the weight of the floating object equals to the weight of the displaced fluid. هذا correct 100%. And that's why those two containers will have the same mass. لكن as you asked, if this was not a piece of wood, it was iron, iron will sink. Why? Because the weight of the iron piece is greater than the buoyant force. This means that the weight of this object is greater than the weight of the displaced water. Maybe some of you will ask, why is it greater? Go step by step. Remember, the buoyant force equals to the weight of the displaced fluid. And that buoyant force is smaller than the weight of the object. This means the weight of the object is greater than the weight of the displaced fluid. Just think about it and you will see it. I'm glad you asked this. That's a good question. Okay. So in summary, إذا كان الجسم اللي بنحطه كثافته أعلى من كثافة المي، هل وزن السائل المزاح يساوي وزن الجسم هذا؟ الجواب لا.
No.
الجواب شو هو؟ أقل. نعم. لكن إذا كان هذا الجسم floating يطفو، إذا وزن السائل المزاح شو يساوي؟ وزن الجسم. Okay. We will come to partial submersion at the end of this lecture. Let's have another question. This is just to make sure buoyant force is an extremely good technique to find out whether a material is pure or not. يعني عشان نوجد هل مادة معينة نقية 100% أو لا. And the most important thing about purity of a substance هو gold. يعني الناس بيهمهم يعرفوا إنه الذهب هل هو نقي ولا مش نقي. تعرفوا الذهب له عيار، في عيار 24، في عيار 21، في عيار 18. What do they mean؟ 24 معناته 100% gold. طب 21 لا، في نسبة من مين؟ مين بيعرف شو بحطوا مع الذهب؟ الذهب عيار 21 بيكون بيور. نعم بيكون نحاس، ولذلك سعره شو بيكون؟ أقل. عيار 18 نسبة الذهب فيه 18 على 24، مش هيك؟ طب how do we know? How can you make sure? Sometimes you see something that looks yellow and you think it's gold. How do we make sure that an object is really made of gold or not? This question is regarding this matter. It is the crown gold. Is the crown gold? يعني هذا الكراون، هذا التاج، هل هو مصنوع من الذهب? This is the question. هل هو مصنوع من الذهب ولا لا؟ When a crown of mass 14.7 kilograms is submerged in water, in water. يعني هذا ال 14.7 kilograms. This is the mass of the crown in air. يعني هذا كتلته وين؟ في الهواء. اضرب بجي بيعطيك مين؟ وزنه في الهواء. طيب إذا وزنه في الهواء 14.7 times G. هذا الوزن في الهواء. When it is submerged in water يعني لما حطيناه في المية an accurate scale يعني ميزان دقيق reads only 13.4 kilograms. يعني إذا هو reads only 13.4 kilograms معناته the weight is less. مظبوط ولا لا؟ Okay. 13.4 kilograms. لو فرضنا جي 10 معناته 134 نيوتن. لكن في الهواء شو كان؟ 147 نيوتن. It was 147 newtons. طب tell me why is the weight that we measure in the water is lesser or smaller than the weight that we measure in air. ليش الوزن في المية أقل من الوزن في الهواء؟
قوة الطفو.
كان في buoyant
نعم.
force.
There is a buoyant force from the liquid. Okay. The question is this crown made of gold or not? هل هذا التاج مصنوع من الذهب ولا لا؟ Look at this. This is a free body diagram. This is in air. We are measuring the mass in air, the weight in air. And this balance reads 14.7 times G as a weight. This is the weight in air. So, what forces act on it? There is the tension force upwards, and there is the weight where downwards. So, since it's in static equilibrium, we can say that the weight of the crown which acts downwards, which is M times G, should be equals to Ft, which is the tension in the string. So W equals to Ft and that equals to M times G, because the weight is the mass multiplied by the gravitational acceleration, and that should be equal to the tension in the string. Fine, no problem. I can write this as W, which is the weight, equals to mg, and equals to, instead of m, I shall evaluate rho object, which is the density of the crown, multiplied by its volume multiplied by g. And therefore, I can say that W equals to rho object times V times G, and I call this equation 1. Remember, what is W? W is the weight that we measure in air. Okay, it's the weight that we measure in air, which is 14.7 G. 14.7 kilograms is the mass, and G is the gravitational acceleration. Now we go to the case in water. Look, what forces act on it in water? It's weight downwards, mg. The weight of the object, it's mg, equals ft prime. Ft prime is the new reading of the balance in water. So why is ft prime smaller than ft? Because you have another force now acting upwards, which is what? Which is the buoyant force. It's not only the balance that is carrying the object now, there is the buoyant force that is pushing it upwards. So I will have mg, which is the weight, equals to the f prime t, which is the reading of the balance in water, plus the buoyant force. Okay? And therefore, mg minus ft, take ft prime to the left, should be equal to f buoyant. Now, mg is the weight. F prime t is the weight on water. We call it the apparent weight. I call it W prime. What is the apparent weight? It is the weight that the balance measures in where? In water. But why is it smaller than the true weight? Because you have another force acting, which is the buoyant force upwards. Okay, so we have W minus W prime equals to FB, which is the buoyant force. But I also know that the buoyant force equals to the density of the fluid multiplied by the volume of the crown. Now tell me, why is the volume of the crown equals the volume of displaced water? Why is the volume of the crown equals to the volume of displaced water? What is the reason for that? Because the crown is fully underwater. لأنه كله مغمور تحت سطح السائل. فهون بيكون حجم السائل المزاح شو بيساوي؟ حجم الجسم. When does this happen? When the object, عندما يكون الجسم fully under the water surface, لما يكون كله تحت سطح الماء. Okay? So I get W minus W prime equals to FB, and I know that FB equals to rho V times G. This is equation number 2. Now, if I divide equation number 2 by equation number 1, I get W minus W prime over W equals to rho fluid Vg divided by rho object Vg. And you see that V times G is a common factor, they cancel out. And you end up with rho object, which is the density of the object, equals to the weight of the object or the crown in air divided by its weight in air minus its weight in the water. I know all this multiplied by rho fluid. I know the rho fluid for water, and I evaluate the numbers. You will get that the density of this object is 11,300 kilograms per meters cubed. Now, if you go to the tables in your book, this is not the density of gold. This is the density of lead. So, is the crown made of gold? The answer is no. What is the density of gold? The density of gold is 19,300 kilograms per meters cubed. So 1 meters cubed of gold will have a mass of what? 19,300 kilograms. The density of gold is 19.3 times larger than that of water. You see, by doing a very simple calculation, you can judge whether a material is made of gold or not, or any other material for. Okay. Let's have another question. Example 1010. This is also from your book. This is a balloon. منطاد. Okay. The question says the following: helium balloon. What do we mean by helium balloon? That this balloon is full of what? Of helium. You see this in the malls. When you go to the mall, you will have some people selling balloons, and those balloons are tied to a string. If you buy one to your brother and your brother suddenly lets off the string, يعني بترك الخيط، شو بصير في البالون? What happens to it? If it's helium inside it, it goes up. Why does the balloon go up? Who tells me? The balloon has helium inside it. While surrounding it, what surrounds the balloon? Air.
Air.
What is the density of air? Maybe you don't know the density of air. The density of air is 1.29 kilograms per meters cubed, while the density of helium is 0.179. So the density of air, now air here, air is the fluid instead of the water, for example. So air is a fluid. Now this balloon has helium inside it and it is in a fluid. Now since the density of the balloon is smaller than the density of the air around it, then the buoyant force will be greater than the weight. So it will what? It will float.
Floats.
Yes, it floats. That's why when you let go of the string, when you have a balloon full of helium, that balloon will immediately rise up. It will go up until it hits the ceiling and it stays there. That's why it rises up, because the helium inside it has smaller density than air. يعني هون الهواء بيلعب دور مين؟ بيلعب دور المائع. ما هو الهواء مائع أصلا. احنا حكينا gases and liquids are called what? Fluids. موائع. الغازات والسوائل يطلق عليها اسم ماذا؟ الموائع. فا balloon inside air around it, it's like a piece of wood inside water. The air plays the role of water, okay? And the balloon plays the role of the wood. So the question is, what volume V of helium, what is the volume of that balloon is needed if a balloon is to lift a load of 180 kilograms? Yani we want to lift this weight, which is 180 kilograms. How big should this balloon be, including the weight of the empty balloon? Yani in other words, this 180 kilograms means the mass, or yani the mass of 180 kilograms which we want to carry includes the mass of this box and the mass of the rubber. انتوا بتعرفوا البالون is made of rubber. Okay, now that balloon has a mass because it's rubber, even though it does not have air inside it, and it also has the weight of what? Of the helium. So this balloon, the mass of the empty balloon plus the mass of this object equal to what? Equal to 180. And he's saying, what volume should this balloon have in order to keep this in static equilibrium? يعني نرفعه ويكون in static equilibrium. Okay, have a free body diagram. What forces act on this box? Its mass downwards. What forces act on the balloon? The buoyant force upwards and the weight of the helium were downwards. Now some of you might ask, where is the weight of the skin of the balloon؟ يعني وين وزن المادة المصنوع منها البالون؟ ما هو موجود في مين؟ موجود في هاي. We included it into the what? Into the 180. يعني هذا مأخوذ بال 180 kilograms. طيب, there is one question. Why did I not include a buoyant force from the air on this box? ليش ما حطينا buoyant force على هاي؟ Who can answer? The answer is, there is a buoyant force acting on this box, but the volume of the box is small, and the density of the air is also small. So the buoyant force acting on it is much, much, much smaller than the buoyant force acting on the balloon. طيب ليش it's much smaller? Because the volume of this box is much smaller than the volume of the balloon. معناها the buoyant force due to air acting on it is much smaller than the buoyant force acting on the balloon. Well, the reason is their volumes. Okay, فهون I will just add ignore, just in case somebody ignore the buoyant force acting on the box. Even if you calculate it, it would turn out to be very small. طيب ليش احنا we ignore it? It's too small, very small. يعني هذا more explanation, because the volume of the box is small. يعني حجم الصندوق صغير and raw air is small too. يعني الرو small والvolume small, القوة كلها راح تكون small. طيب, let's do this question. Let's take upwards as positive. We have FB minus this force, which is the weight of the helium, which is M helium times G, minus the weight of the load plus the skin of the balloon, which is ML times G. L يعني load. All that equal to 0 because it's in static equilibrium, hanging in the air in static equilibrium. Buoyant force is going to be equal to the raw fluid, which is in this case it's raw air, because the fluid in this case is air, multiplied by V, which is the volume of the balloon, multiplied by G, minus, and the mass of the helium is raw helium multiplied by V. Why is this V the same as this V? Because the whole volume of the balloon is inside air, like the whole volume of an object is inside water. So the displaced volume of air equals to the volume of the balloon. Minus mg equal to 0. G's cancel out, and you end up with V equals to m load divided by raw air minus raw helium. This is raw air in kilograms per meters cubed, and this is raw helium in kilograms per meters cubed, and this is in units of kilograms. Okay, so you end up with this volume of the balloon that is required to lift a total mass of 180 kilograms. You should have 162 meters cubed. لاحظوا 162 متر مكعب. طب هذا كم حجمه اصلا؟ هذا بتعداش يمكن الربع متر مكعب. This is maybe less than 1 meters cube. And so the volume of the balloon is much larger than the volume of the box. And so the buoyant force on the balloon from the air is much larger than the buoyant force of the air on the box. So you need 162 meters cubed. Now, this is what I told you, partial submersion. يعني الانغمار الجزئي. Look, this is water, and this is a piece of wood. And remember that the density of the wood is smaller than the density of the water. So it does not sink. What happens to it? It floats. You see, part of the volume of the object is under the surface of the water. So this is the volume of the object that is underwater. while this is the full volume of the object. Which is larger, the volume of the object or the volume of the object underwater? مين أكبر؟
volume of the
أكيد the volume of the object. معناته the volume of displaced fluid يعني حجم السائل المزاح أقل من مين؟ من حجم الجسم كله. Okay? Let's see this example. Volume of object equals to V. Volume of object under the surface of the fluid is Vs. We call it Vs. Okay? لأنه بيختلف. لكن Vs أقل من مين؟ من V. Where is Vs? This is Vs. The submerged volume. The volume of the object under what? Under the water. But what is V? V is the full volume of the log. And you can see the full volume is definitely greater than the volume of the object where? Under the water. So Vs is the submerged volume. Submerged volume of log. log مش log تبع base 10 log of wood يعني قطعة الخشب. Okay. Object is floating in equilibrium يعني هذا الجسم في حالة اتزان شو هو؟ سكوني. Therefore the buoyant force equals to the weight. The buoyant force equals to the weight. Whenever you have a floating object in a liquid, the buoyant force acting on the liquid equals to the weight of that object. طيب. The buoyant force is the density of the liquid multiplied by the volume of displaced fluid, which is Vs, multiplied by G equals to the mass of the object, which is rho object, multiplied by V of the object times G. G cancel out, and you get rho object divided by rho fluid equals to V submerged divided by V. And since Vs is less than V, you have rho 0 is less than rho fluid. And we know this. When the object has a smaller density than the liquid, it floats. And for partial submersion, you should use the density of the object divided by the density of the fluid equals to the volume of the object that is under the surface of the fluid divided by the total volume of the object. Now by this, we have finished the 7th section of chapter 10, and we will stop here. On Thursday, inshallah, I will do the suggested problems up to section 7, and we will be done with this course. Do you have any questions? So before, my advice to you, before coming on Thursday, you should revise all what we did on fluids, particularly buoyant force, before you come on Thursday. I know many of you are lagging behind because of exams. I know that. But make sure before you come, you do what we have done on chapter 10. Any questions?